Okay, everyone, we're starting the first trig/algebra unit. For this first unit, it's going to be compiled of quizzes. There's no end of unit test, just very small quizzes. And we're going to be reviewing some things in this unit. So, section R2, we're going to be discussing integer exponents and order of operations. So, integer exponents just deals with positive and negative numbers where we're not going to use fractions or decimals or anything like that. So, just a rule here, integers as exponents. An exponent indicates the number of times that a factor appears in a product. For example, 7 to the third power means 7 times 7 times 7. And there's a rule, this is what we call an abstract rule, this in this box here. A to the power of n just means it's a times a times a, and a just occurs how many times n appears or is. We call a the base and n is the exponent. Next up, 0 and negative exponents. We got to do this rule before we go over the problems below. So the first one here is anything to the power of 0 equals 1. So if you have 5 to the power of 0, it's not 5, it's 1. And then the other rule for the negative exponent, if we have anything with a negative exponent, what we need to do is kind of flip it upside down in a way, or reciprocate it. If there's no fraction, we'll make a fraction and move the base with the exponent, or I should say the whole power, to the bottom of the exponent, as you can see here. Okay, so let's do some examples on what we just learned with the properties. So 6 to the power of 0 is 1. Letter B, negative 3/4 to the power of 0 is 1. Now, I do want to do an additional example on the side. What if we had a negative 3/4 to the power of 0? My stylus is not working well. What if we had it without parentheses? Well, if you want to pause this, you can test it out in your calculator and look at the difference between negatives in parentheses versus without. You'll find that the negative actually carries over, and it would just be negative 1. See, what's happening is you're actually, when you don't have parentheses, it's just saying 3/4 to the power of 1 is 1, or sorry, 3.4 to the power of 0 is 1, and then the negative is just carrying over. Example 2, we reintroduce the negative exponents. Now, in anything that I give, you are not allowed to have negative exponents in your answers, unless it's a scientific notation problem. But here, the goal is to write each of the following with positive exponents. So, and by the way, you may want to take screenshots for this if you don't have a packet yet. If you do have a paper packet, you want to pause this as we go through this to make sure you are writing down your notes. So when I see a negative and I don't have a fraction, I make a fraction, and then I move the power to the denominator. If I have nothing left on the top, make sure to put a 1 there. So it's 1 out over 4 to the power of 5. Letter B, the negative exponent is in the denominator. So what I would do here is move the power to the numerator, change it to a positive, just like the rule says. If there's nothing on the bottom, we put a 1. However, we're not going to leave our answer like a fraction. What we're going to do is, since it's divided by 1, we just get rid of the fraction. Yeah, this stylus is giving me some major trouble right now. Letter C, we have two negatives, so both of them are going to move their places. So the x is going to move to the bottom. Let's try that again. The x will move to the bottom, giving a, there we go, much better. Giving a change to a positive exponent, and the y will move to the numerator, change to a positive exponent. So whenever you move the placement of a negative, or let me rephrase this, whenever you see a negative exponent, you move the placement of it and you change the exponent to positive. Okay, and that rule I actually, that problem is this rule right here. For anytime we have negative exponents in a fraction, as you can see, we just move the placement of it. A factor can be moved to the other side of the fraction before the sign of the exponent is changed. That's what I just did on letter C. All right, so we're just going to expand upon that. We're going to write this with positive exponents. So my x has a negative, so it must move to the denominator, change to a positive. The y also has a negative, so also move that to the denominator, change to a positive. And the z has a negative, it starts on the bottom, it's got its move up to the top with a positive exponent. So if they have negatives, they move. By the way, if something is not a negative, please don't move it. All right, that's pretty much it for the main lesson. That was really short, so I'm going to guide you guys through some of these, and then I'll leave the rest for homework. That was way too fast of a lesson. All right, so letter A, or number 1, we're going to write without negative exponents, and we're going to simplify. So here I have a negative exponent, so I need to make a fraction, move the power to the bottom, 3 to the power of 7, and then have a 1 on the top. Let's take a look at number 4. 23 to the power of 0. We learned today that anything to the power of 0 equals 1. Number 7, we learned the negative exponent rule. So this m will move to the, we make a fraction and we move it to the denominator. As a positive. This guy stays at the top because it's a positive, and anything divided by itself, we remember, is equal to 1. Give me 1 second, I just got to check my pages real quick. When I put this PDF together, not everything came out smooth, so I'm just making sure that I am doing things in the right order. Okay. Moving on. Number 10. Now, this is a little bit different, and this is why I'm doing some of the problems. In the lesson, the main bulk of the lesson, I just taught you the basics. So what we can do here is treat these things separate. We can do 2 times 3 to get 6. And then for the exponents, we do x to the third times x to the second, and the rule is we're actually supposed to add those together. So x cubed times x squared is x to the power of 5. All right, so number 13 is multiplication. How do I know this? You look in between the parentheses, there's nothing in between. So that means we multiply. Now, if you multiply the coefficients, such as the 6 and the negative 7, that will get negative 42. The 7 is negative 7. Please don't confuse that as a negative exponent. Okay, now we are going to recap some rules on when we multiply exponents. Remember, just like in number 10, what are we supposed to do when we have the same base multiplying, what do we do with the exponents? We are supposed to add them. So listen closely. For x to the negative third and x to the second, we are supposed to add them to get x to the power of negative 1. And then the y's, y to the 5th times y to the 9th, we are supposed to add them to get y to the power of negative 4. Now, we cannot leave our answer like this. We have to clean it up a bit. The negative 42 is going to stay in the numerator. That's a negative number, not to be confused with a negative exponent. So it remains where it's at. The x has a negative, so the x will move to the bottom. So x to the power of 1 at the bottom. Just put x. You don't need the 1. And then y also has a negative exponent. Move that to the bottom, and that would be y to the 4th. So remember, when you change the placement of something, you must switch the negative to a positive. Okay, so we are using order of operations here, as we stated earlier, and I'll show you what I mean by that. So number 16, it is looking like multiplication, but each set of parentheses has an exponent of 2, or I should say has its own exponent. So according to order of operations, we always do exponents before we multiply. So please do not do 4 times 3 and then y times y. You have to do the exponents first. So let me color code this for you. So this guy will be 4 to the second y to the second, which will be 16y to the second. And then the second one, each of those numbers gets applied to the third power. So we'll write times 3 to the third y to the third. So that'll be times 27 y to the third. And then we could multiply here, 27 times 16. I do not have a calculator on me, so just be patient. So that'll be 432 as your coefficient. And then what are you supposed to do with the exponents? If it shows y squared times y to the third, you're supposed to add them. So it will be y to the 5th. Okay, I'll do the last one, then I'll let you guys go on your own. Nope, actually there might be one I want to hit. Yeah, I just noticed number 17. Number 17, the rule we didn't discuss today is, what do you do when you're dividing bases that are the same? What are you supposed to do with their exponents? So we have y divided by y. Remember that we are actually supposed to subtract their exponents. So this would be y to the power of 34. And there is no fraction needed. Technically, that would be divided by 1, but you wouldn't put that. If there's bigger numbers on the top and there would be nothing left at the bottom. Okay, number 19, and now I'll make this the last one. So based on what the rule is I just taught you, we are dividing here with this fraction. So we're going to subtract 2 times. So for the x, we're going to do x to you don't need to write it as a fraction right away. So do this. Go y to the second minus y to the first. I'm sorry, I said y. I meant to say x to the second minus negative 1. It's getting late. I stayed up too late. And then move on to the y's, and you'll be subtracting negative 2 minus an invisible 1. So let's do that little bit of math now. So 2 minus negative 1 would be 2 plus 1, which is 3. And then y's, negative 2 minus 1 is negative 3. Now at this point, don't leave your answer. Do not move on yet. We need to make a fraction. The x to the third is perfectly fine. That'll stay in the numerator. The problem I have is this guy right here. We got a negative exponent. So that guy, that y, needs to be moved to the denominator and change the exponent to positive. Okay, guys, that is it. I'll let you guys go. Your follow-up assignment for this will be to finish up this page here. Assignment R.2.